Greetings and salutations, and thank you for clicking on the video. In this video, I am going to show you how to migrate your Ubuntu 16.04 installation from using a swap partition to using a swap file, and then I'm going to show you how to reclaim that hard drive space where that swap partition used to be. This video is by request. I posted a video just yesterday where we took a look at Ubuntu 17.10, and I mentioned that Ubuntu now has gone to a setup where they create a swap file at installation, and I also showed that that's how I do 16.04 as well. So people asked, show us how you do that. I have gone through this process in past videos, but it's usually been in conjunction with other things. So today we're going to just go from the beginning to the end. We're going to take our time. This is going to be a deep dive video. And for anybody who has any questions about swap and how it works on your computer, yeah, Percy, I'm going to show him how to do this, man. Percy thinks it's cool. He's a cat. What does he know? So that's what we're going to do in this video. We're going to go through it and take our time with it. And we're going to do it with this lowly little virtual machine, which is currently running Ubuntu 16.04, and it uses a swap partition. Before we jump into this, a couple of things to talk about. First of all, do you need to do this? Probably not. If you are running Ubuntu 16.04 and you like it and your system runs fine and you don't intend to be messing around with hard drives and upgrading things, moving things around, you probably don't need to do this. But if at some point you'd like to upgrade your present system drive, you did a stock install of Ubuntu, you used the Ubuntu installers setup when you partitioned it, you didn't do custom partitions, that sort of thing, you might want to change this, especially if you're going to be going from, let's say you have a 250 gigabyte SSD in your machine, you're going to be cloning that or copying it using DD and putting it on like a 500 gigabyte drive because you're adding space to the system. You need to kind of do this first. It makes it a lot easier because either way you're going to have to deal with the swap partition. So that's just one reason why you might want to do it. I just do it because I think it's a better way to manage swap. I can keep track of that swap file better than I can a partition, and it's also simpler. I know it sounds crazy because we're going to go through a lot of steps to get to this, but once you get it set up, there's advantages to doing it this way. Now, this is not for Linux Mint. It'll work on most other distributions, but for Mint, I go ahead and create a swap partition, and I go ahead and create a swap partition on Mint that is as big as the system memory at least, because Linux Mint has Hibernate right up front as an option that you can choose, and without a kernel hack, if you try and hibernate to a swap file, it won't work. Ubuntu doesn't really do that, so it's not a problem. If you need to hibernate your system, don't do this because it's just easier to work with a swap partition. Most people do not hibernate these days. Okay, so what I have done is I have put together a cheat sheet that has the commands on it, and I am also going to be giving you a link to this lovely page right here, which is the official Ubuntu documentation about swap. And I include this in this video because every time that I ever mention anything about swap, a bunch of comments show up, people talking about you don't need swap. A lot of people say, I've never used swap, I've got 32 gigabytes of RAM on my machine, why waste your time with this, it works perfectly for me, all that kind of stuff. Here's my position on this. Every single developer, every single dev, like developer, Ubuntu developer, kernel developer that I have read or heard in a podcast talk on this subject, they all say you need a little bit of swap. It is a resource that the kernel needs, even if you have a whole bunch of memory in your machine. And in this nice swap FAQ page here, they go through all the reasons why you need swap. Also here they talk about how much swap space to allocate depending on what you're going to be doing with the machine. I differ from what they say here because I never ever create a swap space, whether it be a partition or a file that is smaller than 2 gigabytes. And a kind of a funny little thing about this, my brother had this computer that had 512 megabytes of RAM in it. And we installed Linux Lite on this machine. It was an old Dell 3000 with like a Pentium 4 in it. and we installed it, and it only had 512 megabytes, and I created a 2.5 gigabyte swap partition on this machine, and that machine would do almost anything. It was slow, but it had the space. So yeah, I never go much below 2 gigabytes regardless of the memory on the machine. And then here they have suggested memory sizes here. So 8 gigabytes and above, 2 or 3 should be fine, and it goes on and on. You can check this out for yourself. Let's go ahead and jump into the procedure. I'm going to try and make this as simple as possible, but I also want to take the time here to explain what I'm doing. So for those of you who are more adversed in this, they already know what you're doing. This might seem a little slow to you, but for all the novices out there who are just learning, this is a great academic exercise. So do keep that in mind as you watch the video. So on this machine, we are running, go ahead and full size this terminal, full screen it, and I'm going to make the fonts a little bigger for those of you who are looking on, watching on devices that are lower resolution. Right now it's reporting 2 gigabytes of swap. We're not using any of it. We're using htop to look at this. And so we need to see really where the swap is located. It will certainly help if we know. And the command for that is lsblk or lsblock. And it shows us what's going on with the drives. This is a virtual machine, so we have a very small hard drive in it. 14 gigabytes of that is SDA1, which is our system partition, and in this case we do not have a separate home partition. This is pretty much what the Ubuntu installer will do before Ubuntu 17.04. It looks at the drive space, looks at the memory space you have, and then it divides it up in such a way that it will create a partition that is the size of your memory, maybe a little bit bigger, and it sticks it on the end. So since this is a mastered boot record partition drive, an MBR, MS-DOS type partition, SDA1, that's the boot partition, and it has all the other stuff for the system plus data. And then SDA2 is a logical partition, and inside that logical partition you can have a large number of logical drives. So the first logical drive is SDA5, and that's our swap space. And this is what we need to, get rid of and switch over to using a swap file. So how do we do that? First step, we need to create our swap file, and we're going to use it. We're going to do this using the dd command. And yes, you can use fallocate to do this, and some people claim that it's a better way to do it. I do it this way because this is how I've seen it documented in book after book after book, and it's just very familiar to me. There is nothing wrong with using fallocate. There may be advantages to doing that, but it's not the way I do it. So there you go. So the input file is dev0, and that is a virtual device which runs on your machine, and that device does nothing but spit out zeros. Output file is going to equal swap file. All right. And then our block size will equal 1 megabyte. And then for the count, we put in the size of our swap file in megabytes. In our case, I want to create a 2 gigabyte swap file, not gigabyte, gigabyte. And that is a more accurate way of measuring data. So if you're not familiar with the differences between gigabytes and gigabytes, you need to go look that up and figure it out. So I'm going to put in 2048 megabytes, which will equal 2 gigabytes. Actually, it'll be about 2.1 gigabytes. And I like that. I like to do that because a lot of software will report swap size in gigabytes, like htop does that. So for instance, if I would just do 2000 megabytes, which is going to equal 2 gigabytes, it will come up and say 1.9. I don't like that. That's why I'm doing it, really, honestly. So if you were going to do 3, it would be 3072. You just go up that way. Okay, here we go. So that looks good. It should work just fine. And so the system is going to create our swap file. And it would help if I had spelled sudo correctly. You guys didn't catch that and tell me about it. You probably just laughed out there and snickered to yourself that I had made that typo, didn't you? That's exactly what you did. I know it. I heard you. All right, so let's create our file. And this will take it a couple of seconds to actually write out 2 gigabytes of data. One of the advantages to using fallocate, of course, is that it doesn't write data. It just sets aside the allocated space. But I kind of like the idea of writing zeros out. So what we've got is 2.0 gigabytes. Yay! That's exactly what we wanted. Now, the next step, if you are doing this on a drive that is a standard spinning hard drive, you want to go ahead and defragment that file. And the reason why is because if the computer had any disk calls while it was streaming that data, chances are it chopped that file up into a bunch of little blocks. So this is the command that does that. If you are running a solid state drive, an SSD, don't do this. E4 defrag doesn't even work with SSDs, so it's not a problem. You should not defragment the file at all. But if you have a spinning drive, you should. This takes a couple seconds, so we're going to pause the video to wait for this command to do its thing. Okay, it is done, and the E4 defrag program says success. 1 block. That's exactly what we want. So we know that our file is now one big continuous block, and that's going to help with seek time and things like that when the system actually tries to use swap. So the next thing that we need to do is secure the file, because right now anybody else on the computer can read it, and we want to make sure that no other user besides the root user can actually access this file. So let's go ahead and clear the screen to run our next command. Sudo change mode or change mod. It's actually change mode without the E. And we want to use 600 for the file permissions. That would mean that the root user has read and write access and nobody else on the machine does. And we'll do it to the file that we just created. And it's done. So now that we have done that, the next thing that we need to do is make that a swap space for the computer to work with. Right now it's just a file called swapfile full of zeros that only the root user can access. So the command we use to do that is mkswap. And the system has done that, and you see it gives us some feedback information. It also issued it a UUID. We won't be using that, but that's what that long number is there. Now, the very next thing we need to do is to make this file usable. And how we do that is we want it so when the system boots up that it's going to use the swap file. It is not going to try and use the old swap partition. If you do not change this and then you restart your system, and if you go on and delete the swap partition, the system most likely will not boot. It will come up with an error and go, oh, there's a problem here. What do you want me to do? So don't right now just reboot the computer and think you're done, okay? Somebody actually did that a long time ago, and then I had to take them back through the process. It was a client a long time ago on another system. So just making sure that you realize we have to do the next part. So what we have to do now is we have to modify the fstab file, which lives in the etc or etc directory, file system table. This tells the kernel when the computer boots where to look for all the file systems where all the data is stored. So obviously this is a deep system file we're going to be looking at, right? So what we need to do is create a copy. We want to back this up just so we have the original around in case we mess things up too bad. So we're going to do cp etc fstab, and we're going to put that into etc fstab.old. Did I do that correct? Yes, that looks good. So this will create our backup file, and we already did it. So now we need to modify that configuration file. And to do that, just we'll use nano to do this. Sudo nano and etc. You could use gedit if you wanted to, if you run it with sudo, if you're better with that, but I like to use nano. So we'll do fstab. Okay, so here's our fstab file. Now you're going to notice as you look at this that stuff's running off the screen. That's because I'm using such big fonts. And let's kind of back that off a little bit for a second, just so you see what's going on. When the system creates the fstab file, it adds a lot of extra spaces so that all of this at the end will line up. And so that's why it's kind of going off the screen. Just so you could see that and see what was going on. But I'm going to go ahead and make it bigger. And we're going to go ahead and add a line to this file. And I have that on my thing right here. And I'm just going to copy and paste this to make it easy so I don't have to type it. And then we'll talk about what it does. Okay. So go back here. We should be able to paste from the host to the guest. It looks like it's going to let us. Let's put the cursor at the bottom there. Want it to be the last line in our file. Paste. So what this does is it's just like all of the other instructions here that tells the system what to mount and where. The first thing is a file called swapfile, which is in the root partition. It has no mount point because it is swap. The file system type is swap. The rules for the file system is SW, which tells the system, hey, this is swap space. And then these last two zeros on the end, the first one that is the dump, and that basically tells the system, don't try and ever back this up. If there's a problem, if the system crashes, don't try and back anything up. And then the second thing is the last zero tells the system not to use the file system checker at boot time on that drive at all. Just leave it alone. So the next thing that we need to do is go ahead and remove the line that has the call for the swap partition. If you don't take this out, and we didn't take out our swap partition, really all we do right now would be double our swap space. So yes, you can do exactly the same procedure if for some reason you want to add swap to a system. And you can leave the swap partition in place and then create swap files and stick them in there, and that will give you more swap if you ever had a reason for wanting to do that. Folks who run servers sometimes need to do that, depending on if they make like a bad decision when they install their server, they didn't put enough swap space in it. You can get swap space later. So what I'm going to do is cut that line out, and I'm going to use Ctrl+K, and I'm going to go ahead and leave the comment in that says that swap was on dev SDA5 during installation. And then to save, we do Ctrl+O. Yes, okay, so we saved our file, and then Ctrl+X to exit. I will clear the screen here. And so now we have, we're set up, we're good to go. Assuming that everything is the way it should be, then we can reboot the computer and it should go onto the swap file. I'm going to add a little something here just to kind of give you an idea of the mechanism that's going on. We can check the file first to make sure it's going to work before we reboot it. If you're at all uncertain that you got something wrong, you might want to do that just to make sure this works, because if it can't actually mount it as swap, the system might not boot. So I'm going to show you that procedure. It's not on the list, but we'll get into it. So the first thing we need to do is to take swap off of SDA5, and we use a command called, crazy enough, swap off. Tell it where, dev SDA5, no, not 1, 5. Okay, I got it right. So now it should take swap off. To check that, we will run free, and I always use the humanly readable command. You see we have no swap on the system at all, and so we've turned the swap completely off. So we want to see if our swap file is going to work. So let's see if we can get this to work. So it's sudo swap on. All right, let's see if that will do it. Yep, we can run free again. And you see now we have swap, and we're not on the swap partition, we are on the swap file. Everything went exactly the way we wanted it to go. We're good to go, ladies and gentlemen. So the next part of this video, what we're going to do is we are going to actually take the swap partition, remove it, reclaim the space with our big system partition, and then we will be completely done. Before we do that, let's go ahead and reboot the computer just to make sure this worked. Make sure that our entry in our fstab is going to work the way it should. It's always so exciting when you reboot after you change something. It's like, oh my goodness, will it work? Who knows? Well, it made it through the first part of the boot process, so there wasn't an error in that file that made the system think there's something majorly wrong. Which is good. So I think we did it right. Okay. So we'll open up a terminal and we'll run htop, and you will see it's reporting 2 GB of swap, which is exactly what we want. We're good to go. So in order to change the, let's go ahead and cancel that. What we're going to need to do now is to power off the machine, and we're going to have to boot it off of a live USB stick, because you cannot modify partitions on the machine while it is running. So to do that in a virtual environment, all I got to do is go into settings. It took a little while to load there, and we'll go to storage, and this is our virtual CD drive. And we will grab some sort of live image. I've got several to choose from, and it really doesn't matter which one I choose because all of them have the tool that we need. So just for fun, let's do 18.2 cinnamon. And we'll go ahead and say yes. And that is mounted up there. So that's like, it's just like I put a DVD in the drive virtually. That's what I just did. So let's go ahead and boot that machine. And yeah, I mean, I could pause the video at this point and then jump right into what I was doing, but you know, and you say, okay, we're booted off of that. But I want you to see the process, really how it goes, especially if you're new to this whole concept of Linux and how it works. So that's why I'm waiting for these things to boot up and stuff like that, and letting the video record. Also gives you time to, you know, think about what you've learned. A lot of people say, man, your videos are real long. And it's like, yeah, if you already know all this stuff, it's going to be pretty slow and boring for you. But a lot of the folks who watch my videos, this is the first time they've heard of these concepts. You really have to take your time when you're teaching stuff that is brand new to people. So that looks good. So what I'm going to do is I'm going to jump in here real quick and make the fonts bigger. Makes it easier for you to see it, makes it easier for me to see it. Make them real big there. So those of you who are watching on those low-res devices, you've got a chance. And I know it's running in software mode. That's because there's no drivers, because it's a live image. I understand that. Now the tool we're going to use is called Gparted. Gparted is a lovely tool that lets you work with partitions on drives. And it comes bundled up with the live environment that you install from with most Linux distributions, but usually it is not installed once you actually install the system. So to get to it, just boot it off a live disk, or you can install it, but you can't work on the system drive if you do that. So what have we got going on here? Well, here's our drive, and it's just like we talked about. We have this 14 gigabyte partition right here. That is the system. And then we have this extended partition here, the logical, and then there's logical drives in there. So we need to get rid of this, don't we? First thing we got to do before we do anything is turn swap off, because a lot of these live images, what they'll do is, if they see swap space available on the drive in the machine when you boot it up, then it will mount itself up. We want to make sure that that's off. So the next thing that we need to do is go ahead and remove that logical drive. And then we need to come in here and remove the extended partition. 2 steps, because this is old DOS MBR stuff. Now we have our system partition here. Let's go ahead and resize that. So I'm going to right click to get to that. and then I'm going to go ahead and take up the rest of the drive space. I'm just going to reclaim that space. Now what we have is one big happy ext4 partition that has our Ubuntu installation on it. And I'm going to say, yep, that's what we want to do. And then we're going to turn it loose. And of course, it's telling us that we might get data loss. We know that. We're okay with it. This shouldn't take very long for this to do at all. When it is reclaiming free space like that, it doesn't take a long time at all. But if you're shrinking a drive, then it might take more time. So if I, for some reason, wanted to move from a bigger drive to a smaller drive, and I was going through exactly the same thing, let's say I was going to clone this drive, I was going to use DD to copy it to a smaller drive, you never know, you might run into a situation where you'd want to do that. This is as far as I could shrink it, would only be to where that data is showing. So this drive's about half full. All right, so now all we got to do is reboot it, and when we reboot it, we should be done. So we will restart. And hit enter. Linux Mint should automatically eject that virtual DVD image. And it's booting Ubuntu. Yep, it's checking the drive for errors. There were none. It now is loading up GNOME. Should get the login here. There it is. Even the drivers kicked in for the video. I know that because of the way it kind of gornied up there for a minute. Okay. In the home stretch, ladies and gentlemen, I just want to make sure that everything is the way it's supposed to be. Let's go ahead and open ourselves up this here terminal, and we will run lsblock just to see what we did. And you see now we have one big happy partition on that drive. And now we are going to run free command, see what we've got. 2 gigabytes of swap space, none of it used, and an htop as well. That's what it actually tells us that is going on with the system. So I'd say mission accomplished, very successful. We have migrated from a swap partition to a swap file. Thank you very much for watching the video. I'm going to post this, as I said, in the description. Also, I will have the swap FAQ for Ubuntu in there. Happy computing, everybody. Be sure and check out Easy Linux on the web. Check out Easy Linux on Facebook, too. And give it a like if you would, if you are a Facebook user. We just passed 3,000 likes a couple of days ago, and I'm very tickled about that. Also, check out freedompenguin.com. That is run by my very good friend Matt Hartley, and there are a lot of great, practical articles on there showing you how to do stuff like I showed you in this video. So be sure and check that out, and we'll do it again soon. Thanks for watching.